Smartphones are important mechanisms for modern human productivity since they provide practicality, remote working, and ubiquity. They allow for virtually instant communication, access to information, and entertainment. Although smartphones have many productivity enhancing capabilities, there have been concerns raised throughout recent years about excessive engagement in smartphone use. Next, we will see the data of Instagram's usage and notification for 20 days, where usage of Instagram is X and notifications per usage is Y.
I will present about our implementation towards the data. From the data, we need to find the best fit curve with minimum error magnitude to make our model more accurate to the real data by using the least square method. So, the first model is a linear model. The equation of linear model is y equal to a plus bx. To make it easier, we transform the data to the vector form. Firstly, we need to set up mv equal to y, where m equal to usage data of application and y equal to the number of notification to generate system of equation with the metric representation. Then we multiply both vector m and y with respect to m transpose to find its normal equation. For find the constant a and b in vector v, we multiply y with m inverse. Since we get constant a and b, so we can average it into linear form that represent the best fit linear curve. Therefore, the best fit curve is y equal to 74,258 over 8,359 plus 6,606 over 8,359x. To make sure our model is more accurate, we must find the error vector with formula E equal to y minus mv. Since we get the error vector, we must find the magnitude from the best fit line using the vector that we get. So, for the error magnitude for linear is 148.5688. Now, I am going to present about the graph for linear model. So, the first graph is graph for best fit curve against its observed data. The second graph is graph of the error vector against x values. The horizontal axis and vertical axis in both graphs will show the usage data of application in y-axis, and the x-axis will show the number of notification.
Quadratic model is in form of y equals to a plus bx plus cx squared. The matrix representation of the above system is like the diagram shown. So we can compute it using Maple. Next, the normal equation, which we will have the three final answer for A, B, and C, which is 1,120, 65,132, and 4,831,078. So we got the least square solution, which is y equals to the equation shown in the slide. Next, we will calculate the error vector, which is by using the formula E equals to y minus mv, and then we will obtain the error equals to 146.8528. Lastly, the graph for best fit curve against its observed data, which is the quadratic graph, and the error vector against the x values.
So, as the conclusion, the reason for the error stop at a certain degree in those two models due to the random error, which is the precision limitation of the measurement device. So, the best fit curve in this case, which will give the best approximation, is the quadratic best fit curve because it has the minimum error in terms of its magnitude compared to linear best fit line curve. That's all from us. Thank you.